Drying, determination of moisture. In practice, the moisture is generally determined by the samplers, and the proportion is specified in grains per pound on the label attached to the sample when it reaches the assay office. The method adopted is usually to dry 1 pound (= 7,000 grains) of the ore in a frying pan heated over a gas flame, or in an ordinary oven, until a cold bright piece of metal or glass is no longer damped when held over it. The loss of weight in grains = moisture. Properly, however, the work should be done by the assayer, if only for the following reason. It is assumed that the dry ore of the sampler and of the assayer are the same thing. According to the nature of the ore, this may or may not be the case. The assayer, however, uses the sample which he has dried for his moisture determination as the dry ore on which he makes his other assays, and no variation in moisture would influence the other and more important determinations. Some ores are sent to the smelter with from 5 to 15% of adherent water. In these cases it is best to spread out the sample and, taking equal portions fairly at regular intervals, weigh into a Berlin dish 20 grams. This should then be dried over a sand bath, or, if the ore is likely to be injured by excess of heat, over a water bath until the weight is constant. The loss of weight multiplied by 5 gives the percentage of water present. Example: weight of dish plus wolfram 32.67 grams, weight of dish 12.67 grams. Therefore, weight of wolfram = 20 grams. Weight of dish plus wolfram 32.67 grams, weight of dish dried 30.15 grams, weight of water 2.52 grams. 2.52 times 5 = 12.6, moisture 12.6%. There are other ores which are not apparently wet, but in the state called air-dried. It is easier to take fair samples of these, and consequently it is not necessary to use so large a quantity as 20 grams. But with a smaller quantity extra precautions must be taken. All dry solids at ordinary temperatures absorb moisture from the air. The amount varies with the nature of the material and with the quantity of surface exposed. Light, bulky powders absorb more than heavy ones, because of the greater condensing surface. It is on this account that it is well to weigh substances which have been dried between close-fitting watch glasses. The method of determining moisture is to weigh out into the glasses 5 grams of ore and dry in the water oven until there is no further loss of weight. On taking the glasses out of the oven, they should be at once closed, the clip put on, and, after cooling in a desiccator, weighed. If after a second trial the loss is the same, or only increased by a milligram, the determination is finished. Sometimes it may be advisable to dry 10 grams, in which case multiplying the loss by 10 will give the percentage. The dried ore should be transferred to a weighing tube and reserved for the subsequent determinations. The weighing tube with the ore must be marked and kept in a desiccator. Most ores and inorganic substances can be dried, and their moisture determined by the loss in this way. When, however, the substance contains another somewhat volatile ingredient, it is exposed over sulfuric acid in a desiccator for 2 days. Note: if in vacuo, all the better. End note. And the loss determined. Moisture in dynamite should be determined in this way. When water is simply mechanically mixed with a substance, it presents but little difficulty. The combined water is a different matter. Slaked lime, even when perfectly dry, contains much water, and if the water of soda crystals were separated and frozen, it would occupy a volume equal to that of the original crystals. Perfectly dry substances may contain much water, and this combined water is retained by different materials with very unequal vigour. Sodium sulfate and sodium phosphate crystals lose water even when exposed under ordinary conditions to dry air. Soda crystals, when heated, melt, and at moderate temperature give off their water with ebullition. The temperature at which all the water is given up varies with each particular salt. The actual determination of the water in each case will require somewhat different treatment. Such determinations, however, are seldom required, and from a practical point of view this combined water causes no trouble. In assaying ores, we term moisture all water which is lost by exposure in a water oven at 100 degrees centigrade, and the dry ore is the ore which has been dried at this temperature. No advantage, but rather endless confusion, would be caused by varying the temperature with the object of estimating the whole of the water which a hydrated salt may contain. The results of the assay of the other components should be calculated on the dry ore. One advantage of this is obvious. The dry ore has a constant composition, and the results of all assays of it will be the same, no matter when made. The moisture, however, may vary from day to day, and would be influenced by a passing shower of rain. It is well to limit this variability to the moisture by considering it apart, and thus avoid having the percentage, say, of copper rising and falling under the influence of the weather. In the case of certain salts, however, such as soda crystals and hydrated sulphate of copper, when these constitute the bulk of the substance to be assayed, it is as well to perform the assay on the moist, or at any rate air-dried, substance. Note: such substances are best dried by pressing between folds of dry filter paper. End note. It would be equally convenient to calculate on the substance dried at 100 degrees centigrade, but in this case it would be well, in order to avoid a somewhat shallow criticism, to replace the term moisture by the longer but equivalent phrase water lost at 100 degrees centigrade.